Okay, business calculus students. Let me lower that a bit. Okay, I'm using a laptop I haven't used in a while, so forgive me if I do some fumbling around here. Excuse me. Today is October 8th, I believe. Thursday, October 8th, 2020. I just recently posted your first test to your Pearson course shell, or your MyLabs Plus course shell. I think most of the problems in the test are very similar to problems you had in your first homework assignment. There could be a few problems that maybe did not appear in your first assignment. So for this video, what I'm actually going to do is go through the test with you. I'm actually going to do the test with you in the video. Now, be very careful because your problems should be very similar to the problems I'm looking at, but the numbers could be different. For example, here in question 1, I see that f of x is equal to 3x over x minus 3. Well, you know, for you, maybe it'll be 5x over x minus 5, or 7x over x minus 7. You know, you got to be careful. Your numbers could be different. So this is not a situation where it's just monkey see, monkey do. You know, you still have to take the test, and you excuse me, you have to take the test, and you need to use your own good judgment when you take the test. You have to read the questions and ask yourself, okay, are these questions very similar to the questions that Mr. Lewitt did in his video? Okay, so you know, you can't just copy my answers and assume that, you know, you're going to get 100 on the test. That's really not the way to do it. Okay? So let's look at the first question. Find the limits in a, b, and c below for the function f of x is equal to 3x over x minus 3. Use negative infinity and infinity when appropriate. Okay, so here the limit of f of x is x goes to 3 from the left side. So for something like that, for a problem like this, you really need to look at a graph. You need to look at a graph. So let's check out the graph. 3 times x divided by x minus 3. And I want 3 to be in the middle. So if 3, how about 0 and 6? We'll choose a minimum range of 0, a maximum range of 6, which means that the number 3 is right in the middle. Okay, so we can see just by looking at the graph, I mean, I could make this a little bit bigger. Image size 500. I think the default is 300 maybe. 250 or 300 pixels. So image size 500 pixels across. And we can see just from looking at the graph that as I approach positive 3, here's positive 3 right over here. As I approach positive 3 from the left, the curve goes to negative infinity. Here, let me expand this. Okay, where... here we go. Negative infinity. The limit does not exist and is neither... Okay, so for B, hold on one moment. I want to make sure I'm reading this correctly. So, yeah, the limit as x approaches 3 from the left is negative infinity. And here, as x approaches 3 from the right, we know that the limit is simply positive infinity, and we could see that just by looking at the picture. Just by looking at the picture, okay? And for C, select the correct choice below and fill in any answer boxes. Okay, the limit, here we know the limit does not exist, because, and the reason why the two-sided limit does not exist is because the left-sided limit does not agree with the right-sided limit. So therefore you would say that the two-sided limit or the regular limit does not exist. Okay, check answer. Your input is correct. Score 100%. Okay, great. Let's move on to the next question. Okay, and here we go. Okay, my connection is a little slow here today. Okay. That's a bit strange. So we're, okay, hold on a second. It looks like I'm stuck on the, wait a minute. Okay, I want to go to the next question. That's, okay, so I'm having technical issues right here. Hold on. You have not completed all parts of this question. Are you sure you want to leave this question? Yes. Oh, for God's sakes. Okay, it's not letting me go back to question number 2, so that's kind of weird. Okay, well, I'm not going to worry about it. Okay, so question number 3. Yeah, that was kind of weird. So something happened with question number 2, but we're not going to worry about it. It looked like question number 2 is actually a repeat of question number 1. That's kind of strange, but let's not worry about it. For question number 3, find the limits in a through c below for the function f of x is equal to x squared minus x minus 20 divided by x minus 5. Use negative infinity and positive infinity when appropriate. Select the correct choice below and fill in any answer boxes in your choice. Now, first of all, if I'm looking at a rational function like this, it looks to me like x minus 5 might be a factor of x squared minus x minus 20. So let's see if that's true. Factor x squared minus x minus 20. We can make that look a little prettier. Yeah, so x minus 5 is indeed a factor of x squared minus x minus 20, which means this is really the same as the function x plus 4, except there is a point of discontinuity when x is equal to 5. Okay, so what that means is basically this is going to be the straight line x plus 4. So the limit as x approaches 5 from the left side should be 9. 5 plus 4 is 9. Here, hold on one second. And then b, as we approach x from the right side, the limit should be 9. Okay. And as x approaches 5 from either side, the limit should be 9. Your input is correct, score 100%. Okay, terrific. And the reason we're able to do that is because this function looks almost exactly like y is equal to x plus 4 or f of x is equal to x plus 4. The only difference is that when x is 5, the function is not actually defined, but the limit still exists. Okay? Let me try to go back to question 2. Oh, here's question 2. Okay, terrific. Yeah, that was kind of a technical issue. Okay. So find each limit. Use negative infinity or positive infinity when appropriate. Okay, this is question 2. So, f of x is equal to 5x minus 5 divided by x minus 5 to the power of 4. So we have 3 limits to evaluate. What happens when x approaches 5 from the left side? What happens as we approach x from, what happens as x approaches 5 from the right side? So this means what happens when x approaches 5 from the left side, and this means what happens when x approaches 5 from the right side, and this is asking about the two-sided limit. So again, I think we need to see a graph. We need to see a graph. Plot 5 times x minus 5 divided by x minus 5 to the power of 4. And again, I would like 5 to be in the middle, so let's say we go from 3 to 7, which will place 5 exactly in the middle. Image size is, how about 500 pixels? Okay. Excuse me. So as we can see, this function really explodes up to positive infinity, whether we approach the limit from the left or from the right. So from the left side, I know the answer is going to be infinity. Here, let me expand this window. And here again, I know the answer is going to be infinity. All I'm doing is reading the graph. Okay. And here, you would simply say as x approaches 5, I'm approaching infinity. Your input is correct. Score 100%. Okay. Okay, so let's go on. We did question 3. Let's go on to question number 4. Okay. Find the limits in a through c below for the function f of x is equal to x squared minus 7x plus 6 divided by x plus 6. So again, I think maybe x plus 6 might be a factor of x squared minus 7x plus 6. Let's see if that's true. Factor x squared minus 7x plus 6. X minus 6, oh, x minus 1. Okay, so actually x plus 6 is not a factor of x squared minus 7x plus 6. X minus 6 is a factor, but x plus 6 is not a factor. But again, we can, hold on 1 second. Okay, we're looking at what happens when x is close to negative 6. So again, guys, I strongly recommend a plot. We're going to plot this. X squared minus 7x plus 6 divided by x plus 6. And I want negative 6 to be in the middle. So let's go from negative 9 to, let's say, negative 9 to negative 3, and negative 6 is exactly in the middle between negative 9 and negative 3. And, oops, there we go. Okay, just by looking at the graph, I can see that when x approaches negative 6 from the left, I'm going to have negative infinity. Hold on 1 second. And we can see that as x approaches from the right, we have positive. As x approaches negative 6 from the right, we have positive infinity. Okay. As x approaches negative 6 from the right, we are going to have positive infinity. The left-sided limit and the right-sided limit do not agree with each other. Therefore, you would say that the limit does not exist and is neither negative infinity nor positive infinity for the two-sided limit. Your input is correct. Okay, score 100%. Terrific. Let's move on to the next problem. Hold on one second. Let me just clean some dirt off of my computer. Okay, so then let's go on to the next question. Question number 5. Okay, find each function value and limit. Use negative infinity or positive infinity where appropriate. Okay, so the function that they're looking at, hold on one second. The function that they're looking at is 7x plus 3 divided by 9x minus 6. Okay, now in a situation like this, you have to look carefully at the numerator and denominator. The numerator is a polynomial of degree 1. The numerator is a polynomial of degree 1. The denominator is also a polynomial of degree 1. So basically, the 3 and the negative 6 cancel, and you're at infinity. At infinity, you're going to have 7x over 9x. The x's cancel, you're going to have 7 over 9. So I can tell you that for C, okay, for C, the answer is, round to the nearest thousandth is needed. I don't know why they do that. That's kind of silly. 7 divided by 9. Okay, so if I want to round that out, I could just do round 7 divided by 9, 0.001. Okay, so if I want to round to 3 decimal places, that's going to be 0.778, which is really 7 over 9. The real limit is 7 over 9. Okay, now the first two are pretty simple. The first two questions, f of 10. Here, let me, okay. I'm trying to get this a little, there, okay. So I have, let me move the window a little bit. Okay, so I have 7 times x plus 3 divided by 9 times x minus 6. What happens when x is equal to 10? That's 73 over 84. 73 over 84, rounded to the nearest thousandth, is 0.869. 0.869. And we'll do the same thing to find f of 100. 7 times x plus 3 divided by 9 times x minus 6. What happens when x is replaced with 100? 703 over 894. So this means my last answer. If I just type a percent symbol in Mathematica, it means my last answer. 0.001. Okay, so that's going to be 0.786. 0.786. It should be correct. Your input is correct, score 100%. Okay. Let's move on to the next one. So find each function value and limit. Use negative infinity or infinity where appropriate. Okay. So for this one, what I'm going to do, Okay, 1 second. We're going to define a function, f of x, 5 times x to the power 4 minus 10 times x to the power 2, control divide by 16 times x to the power 5 plus 8. Whoops, plus 8, not plus 89. Okay, round to the nearest thousandth is needed, so round f of negative 6, I'm rounding to 3 decimal places, so that's going to be negative 0.049, f of negative 12, round f of negative 12, round to 3 decimal places. It's going to be negative 0.026. Okay. Let's see. Hold on 1 second. And now for this one, select the correct choice below, and if necessary, fill in the answer box to complete your choice. What is the limit when x becomes super negative, a very, very large negative number? Okay. What happens, when x becomes extremely negative? Well, you have to look at the power of the numerator and the power of the denominator. Okay, so we see here that the numerator is a polynomial of degree 4. The denominator is a polynomial of degree 5. Now, if the numerator has a power, if the numerator and denominator are both polynomials, and the degree of the numerator is less than the degree of the denominator, then we know that when x is a very large number, a very large positive number or very large negative number, the limit is going to have to be 0. And we can actually test that. We can go, let's see, f of negative 1 million. That's a very small number. Okay, this is negative 3.125 times 10 to the power negative 7. That's a very small number. So the limit is going to be 0. Your input is correct, score 100%. Terrific. Okay, let's move on to question number 7. Find the slope, if it exists, of the line containing the pair of points. Okay, very easy. Everyone should know how to do this. So here, my slope is simply going to be negative 4 minus negative 9. Oh, sorry. The y values have to be in the numerator. My mistake. Okay. Negative 15 minus negative 18. Control divide by, and then negative 4 minus a minus 9. Okay, so the slope is 3/5. Your input is correct, score 100%. Okay, great. Let's move on to the next one. Determine the slope of the line through the given points. Okay, same as before. Let me just move this window to the side a little bit. So this is going to be 4 minus a minus 9. control divide by negative 2 minus 0. That's negative 13 over 2. Negative 13 over 2. Your input is correct. Score 100%. Okay, terrific. Let's move on to the next one. Number 9. Find the slope of the line that goes through the given points. Okay, again, this is very easy. So we're going to have, remember the y values are in the y difference is in the numerator, the x difference is in the denominator. So 10 minus a minus 4 divided by, or control divide by, and then 4 minus 11. So 10 minus a minus 4 divided by 4 minus 11. Shift enter. That's negative 2. Your input is correct. Score 100%. Okay. So we're almost half done. Find the slope, if it exists, of the line containing the pair of points. Again, I deliberately put these questions in there, guys, because I think these are really easy. They should be very easy for you. Okay. So again, negative 10 minus a minus 13 divided by negative 4 minus a minus 12. Shift enter. And the slope is 3 over 8. 3 over 8. Your input is correct. Score 100%. Okay. Number 11. In parts A to C, find the indicated quantity for y is equal to f of x is equal to 8 minus x squared. Okay. So for this problem, let's clear f. F of x is equal to 8 minus x squared. Or if I want to make it look nice, I can do control 6 squared, to the power 2. Shift enter. Okay, so then we're going to have for part A, f of 2 minus f of 1. Okay, control divide by 2 minus 1. Shift enter. That answer is going to be negative 3. Okay. And for part B, f of 1 plus h minus f of 1 divided by h. Let's expand it, make it look nice. Okay, that's going to be negative h minus 2. And then here we have f of 1 plus h minus f of 1 over h. What is the limit as h goes to 0? So this is going to tell me what the derivative is when x is equal to 1. Well, if h goes to 0, I simply have negative 2. If h goes to 0, I have negative 2. Okay, your input is correct. Score 100%. Okay. And find the indicated quantities for f of x is equal to 3x squared. Okay, we want the slope of the secant line through the points 1 f of 1 and 1 plus h, f of 1 plus h, where h is not equal to 0. The slope of the graph when at the point 1 f of 1. the equation of the tangent line at 1 f of 1. So this problem's a little tricky. This problem's going to be a little bit tricky. What they're really asking for is, well, they're asking for the derivative. So the slope of the secant line through the points 1 f of 1 and 1 plus h, 1 plus h, f of 1 plus h. Okay, so really that's not going to be very hard. Let me remove the function f to make it symbolic. So if we want the slope is going to be f of 1 plus h minus f of 1, okay, divided by 1 plus h minus 1, which is really just h. That's really, because 1 minus 1 is 0, so that's simply going to be h. Okay. And then we could make this look nice. Okay, so at this, okay, so the slope of the secant line through the points 1 f of 1 and 1 plus h, f of 1 plus h with h not equal to 0 is simply going to be, oh, well, we have here, okay, I'm sorry, f of x is equal to 3x squared. Oh, I should, you know what, hold on one second. So I overlooked that part. So f of x is equal to 3 times x squared. So we could actually, well, I'll just leave it as it is. Okay, so then we're going to have, actually, let me expand this. I think maybe that's what they would prefer. So this is actually 3h plus 6. The slope of the graph at 1 f of 1, well, h is going to go to 0. 3 times 0 is 0, so you're just going to have 6. You're just going to have 6. The equation of the tangent line at 1 f of 1 is equal to, okay, so now we have to use the formula y is equal to the slope times x plus the intercept. Okay, so we know that the slope is 6. We know that the slope is 6. So my x value is equal to 1. My y value is equal to f of 1, which is 3. Okay, so we have the equation y value is equal to, notice that in Mathematica I'm using the double equal symbol. The y value is equal to, oh, and sorry, my slope, I should define my slope, is equal to 6. So I have the y value is equal to the slope times the x value plus the intercept. What is the intercept? The intercept is -3. So the equation of the tangent line is going to be 6 times x minus 3. Okay, your input is correct. Score 100%. Okay. Let's move on to the next one. Number 13. Find f prime of x for f of x is equal to -6 times x to the power 8th. 8. Let me say that again. Find f prime of x, which is the derivative of f of x, for f of x is equal to negative 6 times x to the power 8. We simply use the power rule for derivatives. We know that 8 times negative 6 is negative 48. Whoops. Negative 48 x to the power of, and then this power is reduced by 1. So instead of 8, it's going to be 7. And that should be correct. Let's move on to the next one. What is the derivative of x to the power 7 over 35? Well, this is the same thing, really. It's simply 1 over 35 times x to the power 7. So the 1 over 35 does not go away. And then that's going to be times the derivative of x to the power 7, so 7x to the power 6. Now, what is 7 divided by 35? I know that 35 is actually 7 times 5, so the 7s are going to cancel. The 7s are going to cancel, and here I'm simply going to be left with 5. 1/5 times x to the power 1/5 times x to the power 6. Okay, your input is correct. Score 100%. Okay, next question. Oh, let's see. Suppose f prime of 9 is equal to 9 and g prime of 9 is equal to 4. Find h prime of 9 where h of x is equal to 3 times f of x plus 2 times g of x plus 5. Okay. So they're trying to trick you a little bit over here. So in order to find the derivative, so this is where you have to know some of the derivative rules, and this is where you really must read your book. I mean, you absolutely have to read your book, okay? If you're not reading your book, shame on you. You have to read the book. You can't expect to get everything from my videos because I can't make and upload videos for you all day long. So you must sit down and just open up your ebook and read the book. Okay? So h prime of x is will be equal to 3 times f prime of x plus 2 times g prime of x. The derivative, when you add a number to the function and you're looking for the derivative, this number disappears because the derivative is going to be 0. So we're going to end up with 3 times 9, which is 27. 3 times 9, which is 27. And 2 times 4, which is 8. And that's going to be 35. So h prime of 9 is going to be 35. Oh, oops, sorry about that. 35. Your input is correct, score 100%. Okay, that looks good. Find the derivative with respect to x of 7x plus 2. Well, the derivative of the 2 is going to be 0, and the derivative of 7x is just 7. So the answer is 7. Okay. And, okay, there we go. So find f prime of t, which is the derivative of f with respect to t. If f of t is negative 3 times t cubed minus 6 times t plus 1. So negative 3 times 3 is negative 9. T squared, right? The power of the expression is reduced by 1. 3 times negative 3 is negative 9 times t to the power 2, and then minus 6. And that's correct. Okay, so 18 looks a little bit harder. For f of x is equal to x to the 4th minus 12x to the 3rd plus 6, find the following. What is f prime of x? What is the slope of the graph of f? at x is equal to 2, the equation of the tangent line at x is equal to 2, the values of x where the tangent line is horizontal. Okay, so I'm going to cheat a little bit and make this question go a little bit faster. So what I'm going to do is clear f. I have a new f function, x to the 4th power minus 12x to the power 3 plus 6. I'm going to use Mathematica's derivative command. What is the derivative of f of x with respect to x? Traditional form. So this is actually the derivative. Okay, so that's 4x to the power 3 minus 36x to the power 2. Okay, at x is equal to 2, the slope of the graph of f is, okay, so 4 times x cubed minus 36 times x squared when x is 2. Okay, the slope of the graph is going to be negative 112. At x is, okay, that's the slope. At x is equal to 2, the equation of the tangent line is, okay, so I know that my slope is equal to 112. Whoops, shift enter. The x value is 2. The y value is going to be f of 2, which is negative 74. So just like last time, y is equal to slope times x plus intercept. And I have to figure out the intercept. But that's the same thing as y minus slope times x is equal to the intercept. Okay, so my y value minus the slope times my x value is equal to the intercept. The intercept is 150. So we're going to have the slope, okay, it's 150 is the intercept minus 112 times x. 150 minus 112 times x. The tangent line is horizontal at x is equal to, so what we have to do is set the derivative equal to 0. The tangent line is horizontal at x is equal to. Okay, so what we can do here is factor out x squared. If we factor out the x squared, we're going to end up with 4x minus 36. Okay, and the reason you can do that is you have 4 times x cubed minus 36 times x squared is equal to 0. We'll divide everything by x squared, assuming that x is not going to be equal to 0. Okay, so then you're going to end up with 4x minus 36 is equal to 0. Well, 4 times 9 minus 36 is equal to 0. So the tangent line is horizontal at x is equal to 9. I believe, you know what, maybe 0 and 0 as well, because 4 times 0 cubed minus 36 times 0 squared is going to be 0. So actually, it would be 0 and 9. It would be both. Your input is correct. Score 100%. Okay. Let's check that one more time. Yeah, this is correct. Okay, 2 more questions and we are done. If an object moves along the y-axis, marked in feet. Okay, hold on 1 second. If an object moves along the y-axis marked in feet, so that its position at time x in seconds is given by f of seconds is equal to 224 seconds minus 16 times the number of seconds squared, find the following. The instantaneous velocity function, v is equal to f prime of x. The velocity when x is equal to 0 and x is equal to 3 seconds. The time seconds when v, the velocity, is equal to 0. A little bit of a tricky problem, but not that bad. So here, the first part's pretty easy. So the velocity function is given by 224 times x minus 16 times x squared. Okay. And what? Oh, that's the position function. Sorry about that. That's the position function. Okay. Actually, let me clear f and do that again. Clear f and v, and we'll do that again. Okay. So f of x. V of x is simply going to be the derivative, and that's going to be pretty easy. That's just the derivative of f of x with respect to x, which is 224 minus 32x. 224 minus 32x. What is the velocity when x is equal to 0 seconds in feet per seconds? Well, that's simply going to be v. Wait a minute. Let me put my cursor back here. V of 0 is equal to. Oh, I see what happens. I see. Okay, so here. Wait a minute. So what I'm going to have to do is use a different, okay, let me clear, this is a Mathematica issue. So v of x, here, you know what, let me go back over here. Let me use a different letter with respect to y. When y is replaced with x. Okay, v of x, v of 0, yeah, that makes a lot more sense. So v of 0 should be, that was a Mathematica issue, not a calculus issue, 224. And what happens when we have v of 3? 128. 128. The velocity is 0 at x is equal to. So when is this function going to be equal to 0? Well, simply set it equal to 0. 224 minus 32 times x is equal to 0. So solve. V of x is equal to 0. What is x? X is going to be 7 seconds. Which means the position isn't going to change when x is equal to 7 seconds. Oh, your input is incorrect. Score 75%. 75%. So it doesn't like something that I did here. That's a little strange. It's giving me 70, yeah, see, it's giving me 75%. So there's something that it doesn't, that Pearson doesn't agree with. Oops. If an object moves along the y-axis marked in feet, so that its position at time x in seconds is given by f of x is equal to, excuse me, 224x minus 16x squared, find the following. The instantaneous velocity function, which is the derivative of f of x. Okay, that should be okay. The velocity when x is equal to 0 is 224 minus 32. Well, 32 times 0 is 0, so it's just 224. That makes perfect sense. And then 224 minus 32 times 3, that's 120. Oh, no wonder this is a typo. Sorry, it's just a typo. So I put down 128 V. That was just a mistake. Okay, sorry about that. Okay, so your input is correct, score 100%. The reason it gave me 75% before was because I typed in an extra character in this box. I put in V, and it's just 128, so that should be fine. So your input is correct, score 100%. And then let's look at the very last question. Same idea as before. An object moves along the y-axis marked in feet so that its position at time x in seconds is given by the function f of x is equal to x cubed minus 6x squared plus 9x. So I know that the velocity function is the derivative. It's simply 3x squared minus 12, minus 12x plus 9. So that's going to be my new velocity function. So clear V, so my velocity function is going to be 3 times x squared minus 12x plus 9. Okay, and the velocity of the object when x is 1 second. I hear my dog coming by. That's going to be 0. And the velocity is 0. Well, the velocity is 0 when x is equal to 1 second, although, let me see, there could be another answer. So the velocity of the object at x is equal to 1 is 0. So solve. V of x is equal to 0. What is x? Okay, there are two answers here. So x is equal to 1 and also x is equal to 3. So when x is equal to 1, the velocity is 0. When x is equal to 3, the velocity is also going to be 0. So if the velocity is 0, that means the position is not going to change. So check answer. Your input is correct, score 100%. Okay, submit test. Yay, I get an A on the test. Okay. Excuse me. And it took me 56 minutes and 18 seconds to complete the test. Okay. So, guys, this is basically, so this is the deal. You really need to do some serious studying. I cannot do all of it for you. I realize, excuse me, I realize that some of you are frustrated because this is an online course. We don't meet for regular video lectures, and even if we did, you know, that's not always the best way for students to learn, you know, to just spend your whole day sitting in front of a computer. I'm not sure how healthy that is for people. And, you know, I understand the situation is really not great for anybody. It's not great for me either. I don't like to teach like this. But the bottom line is we're all kind of stuck in this together, and we're going to have to make the best of it. And I can't just give you an A just because you paid for the course. That's ridiculous. You know, you actually have to do the work. You know, I have to grade the work that you do. I can't just give you an A because you paid some money to Oakton Community College, right? I have to give you a grade based on the work that you do for me. All right? So I basically just took the first test for you. You know, I took the first test for you, and honestly, there's no excuse for anyone in the class to get less than 80% or 75% on this test. You know, I basically did the test for you. So guys, start using Mathematica, start reading your textbook, and really invest some energy in the course, because otherwise you're not going to get much out of it, okay? And you may not even pass. So remember, we are going to have 4 tests. We are going to have 4 tests. I'm not sure how many assignments and quizzes, you know, that depends on how the semester goes, but we definitely have to have 4 tests, okay? I think this video has gotten long enough, and I wish everyone good luck on the test, and have a fantastic week, and I think it's time to finish.